Welcome to New Hour Science Practicals. My name is Mr. Mason, and today we're going to be looking at series and parallel circuits. So the aim in this practical is to compare how potential difference changes around series and parallel circuits, and to look at how current changes as well. Now, current isn't something we've looked at much yet, but when we talk about what electricity is, when we're talking about electricity flowing, what we're really talking about is electric current. Now, that's what we're aiming to look at in terms of what we need to know. But in terms of what we're going to do, we're going to inquire, we're going to look at our inquiry skills. So we're going to select, plan and carry out a scientific inquiry. We're going to perform some predictions. You're going to be looking at independent and dependent variables. We're going to analyse, so you're going to look at your data and you're going to look for patterns in the current and the potential difference. And finally, you're going to present observations and data, draw some conclusions, before presenting explanations for your data, which is your communication skills. So there's a lot going on today, so let's dive in. Now, before we get into doing our scientific investigation, we need to first make a hypothesis about what we think is going to happen. Now, this isn't a guess. This is us saying, based on what we know, when we do this investigation, we think this will happen. I'm going to come over to the visualizer. I'm just going to show you what you're going to see when you do your investigation on the computer, or on Teams, or if you've got a pack at home. So there are these two circuits here, and another circuit here. One circuit, two circuits. So this is our, what we call a series circuit. We know it's a series circuit because if I start at the battery, I can only do one loop as I go around it. We ignore the voltmeters. And this is a parallel circuit because if I start at the battery, I can go all the way around the circuit, and there are two ways for me to do it. Remember, we can't go backwards. We start at the long end, the positive end, and we go to the negative end. So there's two different paths I can take, even again, ignoring the voltmeters. So first thing I want you to do, I want you to identify the variables that you could change in the circuits above. Pause the video at this point and have a go at identifying those variables. Okay, so hopefully you've had a think about what variables we could change. So we could change, for example, the number of batteries. That would change the potential difference across the circuit. We could change the number of resistors we've got. That would reduce the current. And it would also increase the resistance of the circuit. So any of those three things, changing the number of batteries or changing the number of resistors. So I want you to now complete this second task on your worksheet before we get into the experiment. Pause the video at this point and have a go. Okay, let's look at the method then. So let's get into the actual experiment we're going to do. So the experiment we're going to do is actually based around this sheet, and this is what we're going to be filling in today. So on the sheet, it shows you there are 4 different circuits that you've got to investigate. So what I'm going to do is I'm going to build each circuit. You can have a look at it, and then we're going to measure the current in each circuit and the potential difference in each circuit. So starting with, we're going to start by looking at experiment number 1, this one here. So I'm going to set it up with some batteries. This is showing 2 batteries, but in order for the bulbs to be bright enough for you to see, I'm going to use quite a few more. We're going to have 2 bulbs and we're going to have 3 ammeters. And it's a series circuit because once again, I've got one loop going all the way around. So let's build that for real. So here are my batteries, as I said, well, these are my cells. The minute I join more than one together, I make it into a battery. So this is now a battery, because it's more than one cell. And when I'm doing this, I'm gonna, like I said before, I'm gonna use multiple cells, more than the 2 in the diagram, because I want the bulbs to be nice and bright. Okay, so now I've got my battery set up. So I'm starting at the positive end, that's this end of the battery, and on the diagram, I'm working my way around the circuit from here. So always start the positive, the long end, and work your way around from there. So next I come to an ammeter. So I'm going to grab a wire, that's what each of the lines represents on the diagram. And I'm going to connect it to an ammeter. I can see it's an ammeter because it's got an A on it. Now what end of the battery did we come from? That's right, we came from the positive end of the battery. So I'm going to put it into the positive end of the ammeter. Now loads of people will tell you, don't worry about the minus sign on the ammeter, that's just a mistake, ignore that, da, 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 da. It is actually super important, it's really important, because it's telling you the direction the current's going. Now, those of you who tell you should ignore it, it's probably because they've connected it up wrong. They've probably got it going into the negative end when it should be going into the positive end. Easy mistake to make, but now you know how not to make it. So I'm going to grab one of my bulbs, and I'm going to plug it in. Go back to my diagram over here. I can see that I've now added this bulb, another wire, and then my bulb. So now I need to add another wire, an ammeter, a wire, a bulb, a wire, an ammeter, and then a wire back to the battery. So I'm going to do that now. Okay, now hopefully you just saw the bulbs have lit up, which is a good sign. My ammeters are currently off, which is why they're showing no reading. But what I can see, if I look carefully, now I can see the value changing. That's completely normal, that's completely fine, because these ammeters are measuring a very small value. So that means there's a large uncertainty. If you measure a bigger value with an instrument, your percentage uncertainties become much smaller, so they will vary by a smaller amount relative to the value you're measuring. But because these have got low currents, the value might take some time to settle. So I've got 0.03 amps here, I've got 0.03 amps here, and 0.03 amps here. So I can safely say, and I'm just holding it up here so we can see on this camera, I can safely say, oh, we've lost a connection, I think, somewhere. In the battery. Won't work without the battery. So we can safely say that all the way around the series circuit, starting at the positive end and following it around, all the way around, you've got the same current. That's because current is like water. Yeah, what we put in, we're going to get out. If we put a certain amount of water into one end of a tube, we're going to get a certain amount out of the other end of a tube. We don't lose any water. And that's the same with current. It flows around our circuit. So on my diagram, my instructions were to write the current or potential difference readings on the diagram. Okay. So my readings, A1 equals 0.03 amps, A2 equals 0.03 amps, and A3 equals 0.03 amps. Okay, now there's one other thing on my method, if you're following along on the sheet at home, that it says to do, which is to switch the circuit off. Number 3, unscrew one bulb in each circuit and write down your observation below each diagram. Remember to replace the bulb before leaving the station. So I'm going to unplug one bulb. I'm going to unscrew it carefully. Okay. Now, what happened to the other bulb? That's right, it's gone out. The other bulb's gone out. The current now has nowhere to flow. It's as if I've made a break. Remember that pipe model I was telling you about the current? It's as if there's a break now, and so the water isn't able to flow around my circuit anymore. Now, current isn't escaping like water would, that's a weakness of the model, but it's no longer flowing around, as it were. That's a strength of the model. So if I add the bulb back, the bulbs come back on. So I'm going to add that to my diagram. If a bulb is removed, the other goes off. Okay, check number 4. Switch the circuit off. Repeat at the next experiment until you have visited all 4 circuits. Now there's no switch in my circuit, so I have just removed one of the cells and that has disabled it. Okay, so that's the first experiment. Experiment number 2. Okay, so far we've looked at how current varies in the circuit as we go around it. Now we're going to look at how potential difference varies in the circuit as we go around. So looking at the diagram, this was the circuit we had before, and this is the circuit we've got now. So I need to take out these ammeters and I need to replace them with voltmeters. But notice the difference. Here, the ammeters are in series. The wire goes through the ammeter to get to the bulb. Here, the voltmeters are in parallel. The current could go through the bulb or through the voltmeter. Now, the voltmeter's got an infinite resistance, so no current, practically an infinite resistance, so no current actually goes through the voltmeter, but we can see they are on a separate branch to the bulb. We still call it a series circuit because we don't count the voltmeters, remember, but the voltmeters, each one is in parallel to the component it is measuring the potential difference across. We've also got to include a switch in this circuit because that's what it has on the diagram. So let's get started. So I've constructed my simple series circuit. I haven't got any voltmeters in it yet though. I'm going to add those, but first I'm just going to check it works. I close the switch and the bulbs light up. I open the switch and they turn off. So that's working. So now I'm going to get my voltmeters. Once again, as with Mr. Bearson's video, we know these are voltmeters, they've got a V on them, and we measure potential difference in volts. So I'm going to have one of those across the bulb, just like in the diagram here. Got the voltmeter across the bulb. So to do that, I'm going to place one end here and one end here. Now, it might look a bit confusing because I've crossed the wires there, those of you who are watching closely. Now, the reason for this, as I said with the current one, is because this end is the positive end of the bulb because it's connected to the positive end of the battery. So what that means is this needs to be connected to the positive end of the voltmeter with the plus. The other end is the negative end, so that's connected to the negative end of the voltmeter. If we did it any other way, it would come up with a wrong reading. Now, I've just realised when I turn my voltmeter on, no number comes up. So the battery must have run out on that voltmeter. I'll just grab another one. Okay, I've now got 3 working voltmeters, so I'm going to plug this first one in, just like I described. I've got my second voltmeter, also working. I'm going to plug that in. Now, for the first time, I'm going to use a black wire. Does anyone know what a black wire does differently? Absolutely nothing. Well done. Yeah, it's just a colour. Now, sometimes you want to use black and red wires to help you see what's the positive end and what's the negative end more easily. But with the simple circuits we're doing, it's really not something we have to worry about. And my final voltmeter, I'm doing across the battery. So if you look at the diagram here, you've got the battery here, and you've got the positive end and the negative end of the voltmeter going across it. So here's the negative end. I'm just going to put that in front there, make that a bit easier. And here's the positive end. Okay, could do with some longer wires actually, that's close enough. Okay, so we've got our series circuit set up, it still turns on, and we've got our 3 voltmeters in it now. So I'm going to turn each voltmeter on, and we're going to take the readings from each one. So I turn my circuit on, 3.05, careful. Now it's probably changing because as I wiggle my thumb, I'm changing the resistance of the switch. Okay, so I've got to be careful. It's not a control variable, but it is something I do need to control. So I guess you could call the resistance of the switch a control variable. So 3.06 for the first bulb. So we start at the battery, the first voltmeter, 3.06 volts. For the second voltmeter, let's go back around, push it in, 3.16. Oh, nearly forgot, volts. And for the third voltmeter, 6.15. Now, what do we notice when we look at these three? Well, look carefully. 3.06 plus 3.16. That makes 6.22 volts, which is roughly equal to this 6.15 here. So these two are approximately equal to this one. Now, why is there that difference? Why is this value coming out to be bigger than this value? Well, we saw the values changing. We saw that there's some inconsistency. Now, if I'd been able to take the three readings simultaneously, then perhaps this inconsistency wouldn't exist. Perhaps there's some lost volts going on here that we've actually, when I was playing with this switch, I didn't keep it completely in the right position. So the resistance of the switch changed. Now, the other thing I need to comment on here is what happens if a bulb is removed. So I'm going to take one bulb out. And just like before with the when I was measuring the current, I've taken one bulb out and now the other bulb won't shine. Let's just check what happens. I try again. And now the bulbs will shine again. So I can add that in my box here. Okay, current in a parallel circuit now. So I've got two loops now, one loop with the first bulb and one loop with the second bulb. So I'm going to set that up and then we can measure the current at each point in the parallel circuit. So I'm going to take these voltmeters out. I'm leaving the wires in there because it's just going to keep the whole circuit a bit tidier and should make it easier when I measure the potential on the next one. Okay, so now I've got my circuit back. Has it got a switch in it? No switch in this current one. So I'm going to take the switch back out. Okay, you can see the bulbs light up. Now I'm looking carefully at it. I've got an ammeter before the first bulb and an ammeter after that first bulb. And that's all on the first branch. So I'm going to take two gaps here. So I start at the battery. I go into the first ammeter. I then go out of the negative end into the first bulb. We've gone this bit. I'm now on this wire going into an ammeter. So I'm going to grab another ammeter into the positive end. And from that ammeter, I go back to the battery. So I can take this wire that goes back to the battery and pop it in there. And I've got a nice bright bulb. Look how bright that bulb is. Amazing. Right. Now I'm going to do the other branch. So instead of going from the ammeter into the first bulb, like I did here, I'm going to add another branch. So I'm going to add a new wire from coming out of the ammeter and going into the second bulb. From the second bulb, I go into a third ammeter. Here's my third ammeter. Going from the bulb into the ammeter. And then from that ammeter, I go back to the battery. But if you look carefully, there's no gap between the end of this ammeter and the battery. There's nothing in between here. So I can plug the end of this ammeter into the end of this ammeter, and it's the same as going all the way back to the battery. And I'm just going to do that because my wires are quite short, and so that will look a bit nicer. Okay, now something you might have noticed immediately is look how bright those bulbs are. They're far brighter than they were in the series circuit, but I've not changed anything. I've got the same number of batteries and the same 2 bulbs. The only difference is it's a parallel circuit now rather than a series circuit. Let's see if there's a difference in the current, shall we? So here's the current on the first ammeter, the second ammeter, and on the third ammeter now. This is a reading of 0.11 amps. Look at the second ammeter now, A2. This one here comes after the first bulb, 0.09 amps. I thought that seemed a bit high. So the reason that value is so high, and I can tell because I know what's going to happen, I'm using my scientific inquisitiveness just to see if I've set it up correctly. And the reason was I set it up wrong. I plugged the output of this one into the input of the second ammeter, whereas I said in order for it to work, it needs to be on the output. Now that reading is 0.05, not 0.09. And ammeter 3, which is this one, was also 0.05. Okay, and let's do our bulb test. If I take one bulb out, I'm going to take this one out this time. The other bulb stays on. And if I plug this one in and take this one out, the other one stays on still. Why is this? Well, it's because in the series circuit, if I took one bulb out, the current stops flowing. You can't get through. Whereas here, if I take this bulb out, the current can just go this way. If I take this bulb out, the current will just go this way. So let's write that down. If a bulb is removed, the other stays on. Now what's the other thing to notice? Look, the current here, when we've got before it splits off, is roughly equal to the current here. The sum of these two currents in each branch, 0.05 and 0.05. There's a little bit of difference. This probably comes from a bit of resistance in our wires, maybe there's slight differences in the bulb, maybe we've got some lost amps in the ammeter itself. But overall, these two are almost exactly the sum of this one. Sorry, the sum of these two is almost exactly this one. Okay, our final circuit then. We still want a parallel circuit with our first branch here and our second branch here. But once again, we've got to connect our voltmeters in parallel. Good. So our voltmeters are connected in parallel, not in series like this. So I need to take my ammeters out and replace them with 3 voltmeters. So there's loop 1 built. Loop 1. It does want the switch to be in this one. So we'll pop that in. Still works, still just as bright. Now I'm going to get voltmeter to go across. There's the positive end, there's the negative end. Okay. Putting a voltmeter across the first bulb And now we're going to build the second, oh, careful, nearly broke it. Going to put a voltmeter across the second one now, which is just the same as connecting it to the output of the switch here, and then connecting it all the way back to the start of the circuit. Okay. And once again, I'm going to connect the voltmeter across this bulb, like so. So we've got 3 voltmeters now, 2 bulbs connected in parallel. It looks quite complicated, it's got a lot of wires in here, but it's just like this diagram. The first loop here, and the second loop here, and a voltmeter connected across each component. Okay, I'm going to turn my voltmeters on. I'm going to close my switch, and bang, they both light up. Now I'm just going to wait for them to settle. I'm going to try and hold the switch closed as carefully as I can. 5.97. The first one, 7 volts. And on the second one, oh, steady, 6.08. And the third one, 5.98. Curious. So do you remember what happened last time? When we got our readings, we said that the voltages add up when it was in a series circuit to make the overall voltage. But the currents were the same everywhere in a series circuit. But in a parallel circuit, it's swapped around. In a parallel circuit, the currents add up. The current in each branch equals the current in the first branch, in the main circuit. But in a potential difference in a parallel circuit, the voltage is the same everywhere. This is because we can use our hill model of the potential difference if we wanted. If this is the top of a hill and this is the bottom of the hill, well, the top of this bulb is at the same point as the top of this one. And here, the top and the top. And the bottom of each hill is the same across all 3. Okay, our final test then, if we take one bulb out, what do you think is going to happen? Make a little prediction. I've removed one bulb, I've got one bulb still in it. Is it going to light up? Absolutely right. Swap it over, let's try the other bulb. Oh, and it still lights up. So, if a bulb is removed, the other stays on. Wonderful. Why is that? Well, that's because you've got that extra option for the current to flow through. If we take out this bulb, the current can still get through this way. If we take out this bulb, the current can still get through this way. Whereas in a series circuit, if we remove this bulb, the current can't get through anymore. So the circuit no longer works. This has been an investigation into series and parallel circuits. My name is Mr. Mason, and thank you for watching New Practical Science. See you next time.